the recording. All right, so today's lecture is going to focus on combining some things within the backend. So you guys now know how to use SQL and how to build database, how to run queries, stuff like that. And you guys also know how to write code in Python and manipulate CSV files and other things. Wouldn't it be great if we had a way to use Python, which is such a versatile language we can use for data processing and, let's just leave it there for data processing, to connect to our database? But SQL is structured query language. Python is not structured query language. How can we make the two interface? That is going to be our challenge for today. So there's a repository that we're all going to clone down, which is the book publisher database repository. You guys can find it, a link to it on the week 11, day 1 page. So go ahead and clone that down. Feel free to follow along with me if you want. Just going to cd into it, and then we'll just open it up in VS Code and see what's inside. And okay, that was not supposed to happen, but we'll give it a second to unpack everything. And switch over. All right, so we've got a series of 4 files within our book publisher database. We have a Docker file, we have an init.sql file, we have our README, and we have our setup.sh. So let's go ahead and check out that init.sql file just to see what's in there. So, let's see. Katya, what do you see in the init.sql file for book publisher DB? Like what is being created? Maybe what are some of the relationships?
So I am noticing there are tables being created pertaining books. There's also a table for authors, genre, book author, and book genres. It looks like, let's see, some of the relationships are, so I see in book authors, the field book ID is referencing the book table, and the field author ID is referencing the author table as well. And my assumption would be that, for instance, this is a table that's being used in order to allow for maybe a many-to-many relationship between authors and books. And it looks to be something similar happening for book genres.
Exactly. Perfect. So yeah, we have these 3 tables. You have books, authors, and genres. We have many-to-many relationships between books and authors, and many-to-many relationships between books and genres. And then after that, we have like a couple of hundred rows of sample data, which we definitely do not need to bother about reading. But okay, perfect. So this is our database. I haven't done anything to start running or to set up the database yet. But if we go to our setup.sh file, which again is just our standard setup file, this is for running our Docker build. So if we were to run the setup.sh file right now, what does this file do? Can anyone just like roughly describe it?
It will build the Docker file using the Docker file that's located in the folder. Then it's gonna run it, set a password under the name that it builds the image. Then it's gonna wait for 3 seconds, maybe. I don't know what the timetable on that is, but then it's gonna execute the file. So it's gonna well, actually, it's not gonna run on bash because or will it? There's like a -d there. So, it's basically just going to run the database so you can like go into it and make queries and whatnot.
Pretty much. So What we're gonna do now, though, is we're gonna play around with the setup file just a little. Apologies, got a bit of a cold today. So instead of just building it, running it, and then executing into it, so that way in the console we can open up our database. What we're gonna do instead is map the port from, well, originally the port that we had everything running on is port 5432 for Postgres. But what we'd like to do instead of using that port for everything is to map our host port to the container port. So that way, our Python application, which is going to run separately, is able to interface with the Docker container and the database with it. So we're just going to simplify this a little bit. Basically, these three lines are going to get adjusted very slightly. So instead, now we're going to just change the port, just mapping it from 5444 to 5432. That's about it. I mean, the setup still stays the exact same. We haven't really changed anything or done anything different. Okay, so that was step one. The next thing that we want to do is now we've basically got our Docker part made. So what I'd like to do now is do the Python stuff. So it would be a little bit inconvenient to run the Docker database code in the same place as the Python code. Number one, it might mess things up a little bit when we start pushing things into Docker. Number two, in general, when programming, especially with like bigger projects, people usually keep their database in a different location from their backend code and algorithms, which is also usually in a different location from the front end stuff. So let me go back into my terminal. So we're just going to go out a little bit. Let's go ahead and make a new directory, and let's just call it like backend code. And then make sure that was created, and then we'll cd into backend code. Okay, so there's nothing in that folder right now. I'm just going to open that up in a new VS Code window. In a second, that'll open the background. We'll switch to that in a minute. But there are some things that we need to do before we can start messing around. So in general, when we deal with Python and we're importing libraries, how can we constrain our libraries so that they aren't just uploaded in our entire computer?
Virtual environment.
Perfect. Thank you, Vincent. So what is a virtual environment?
It lets you like have custom PIPs. I'm not really sure what they're called, libraries, and it's like a clean slate basically. So anything you install into it, you're not gonna. It won't affect the rest of your terminal or bash, whatever.
Exactly. It's basically like a little petri dish that you can use to experiment in. It's completely sanitized of most things that are on your computer when dealing with Python. So to create a virtual environment, say Python -m venv, and then you can say the name of your virtual environment. Normally, most people just call their virtual environment venv because it's easy, and that way you can remember what it's called. So give it a second for it to work. Okay, it looks like it worked for now. I'm just do an ls. I now have a folder called venv. That's the way that you can check that the virtual environment was created. However, I'm not in my virtual environment just yet. In order to enter it, does anyone remember the code that we need to type to log in to our virtual environment?
Is it a source and then the file name?
Which file?
Ooh, I don't know.
Okay, that's all right. But yeah, the first thing we have to do is source. after that, anyone remember? It's been a little while since we've done the Python stuff, so if not, that's okay.
I think you have to go.
Go.
Go ahead, Vincent.
You do the file paths, and then activate, I think, at the end.
Yep, it's to activate. Does anyone remember the exact file path?
You have to go into the virtual environment, and then I think it's the bin folder.
Yep. bin, and then activate. And that's it. Now our virtual environment's activated. We can tell because in your console, you see that little VENV symbol, which is a handy way to let you know, hey, you've got a virtual environment that's now made. Okay, so we're now operating in our virtual environment. So now we want to download some libraries using a pip install that will let us interface with SQL. The main library that we use to do this is a library called scicopg2. So we're going to do pip install scicopg2, but do not just pip install regular scicopg2 because it will not work. You need to install the binary version. So pip install scicopg2 -binary. And we'll hit enter. You see here that it's already collected, it's installed, and that worked. So the way I can check that it's been installed as well is by doing a handy little pip list. We see here that scicopg2 has been installed in my virtual environment. So now I can do stuff with scicopg2. Okay, so let's go back to our brand new folder with our little virtual environment. And let's go ahead and create a, let me move this. Go ahead and make a little Python file for ourselves. And we'll just save this as, let's call it database script. Because we're designing a script to deal with our database. Oh, wait, let me switch to VS Code. Okay, can you guys all see my VS Code now?
Yeah.
Okay, perfect. So the script that we're writing is going to directly interface between our code and between our Python code and our SQL database. So the first thing that we need to do, obviously, is import the library that we just made. So we're going to import scicopg2. So you're not going to import the binary. You're just going to import the regular old library that we imported. Okay, after that, there's a few steps that we need to take. So first, we need to connect to our database. The way we can do that is by simply saying with scicopg2 dot connect. And we have a bunch of parameters that we need to input in order to connect to our database. Now, connecting to our database using scicopg2 is going to look very similar to connecting to our database using the terminal that we do usually when using Postgres. So the first thing that we need is information about the host and the port. So our host is going to be the local host. The port is going to be 5444, which again is the port that is forwarding the request to the container. So if you guys remember back when we made the setup.sh file, which is here, we specified that we would use port forwarding from 5444 to the port 5432, which is where our container is going to live. Our container lives here. Our application lives at 5444, and that is the port that we are referring to in our database script, because that's where we're going to live. All right, so we specified the host, we specified the port, so it's now knows where to look and what port to operate from. Okay, great. Now, obviously, we can't just connect to a port. We have to do something in that port. What's something that we should do? Well, we need to look at a specific database. The name of our database is going to be the books database, and we've got a few more things that we need to specify. Oh. Number one, we need to know what user we need to log in, and we're using the Postgres user, and then the password for our user. Where's the password? It's just going to be password because that's what we set it up as previously. And yeah, I think that's pretty good. So we'll say with scicopg2.connect, but we can say what exactly the with is being specified as. I'm going to say with this as, I'll call it con for connection. And then we'll just like do stuff inside of there. So all that the first part of this is doing is it's letting us connect to the database via localhost port 5444. We're going to look at the database books. We're going to check that database by logging in using the username Postgres and password. Okay, great. So once we're connected to the database, we need to actually be able to do stuff in that database. And this is where something called a cursor comes in handy. So we're going to create a cursor, which lets you step through, number one, go through the database, send queries, things like that. So let's say with connection or con, and then we see a bunch of options. We're going to say cursor. Well, with con.cursor as cursor, which again just creates something for us to directly interface with that database. Let's just run a really simple query. So the way that we run a query is by saying cursor.execute, and that runs a singular query. Can someone remind me how to select all of the fields from a given table? Or all
Select
entries?
star from the table name.
Yep, so select star from, and let's say I want to find all the authors. And don't forget your semicolon. Or actually, we don't even technically need the semicolon. We can leave that out. So what are we doing here? We're telling Python, we're telling this to execute a SQL query using Python. Apologies. Again, cold. How cool is that? So again, Python and SQL do not natively interface, but using scicopg2, they can't. However, we're not done yet. So we have it execute this query, select star from author, but we can't actually do anything with it, with our result. The only way to get the result back is by fetching the data back. So how do we fetch data? I'm glad that I asked. There is a fetch all method, and we can literally just say like data received or like query answer is going to be equal to cursor.fetchAll, which gives us a response or whatever data we have that came back. And we'll just, make it nice and simple. We'll just print out the data or print out our query answer. So then we can see the result of our query in the shell. That's all. And there are, there's other ways we can make it more complicated hypothetically as well. But again, all this is Python code at the end of the day. So any questions about the code part of things?
Did you run the setup file for it to work?
Nope, nothing has been run right now. We're just doing all of the setup.
And you're able to get an answer from
Nope.
the print? Oh, okay. Got it.
Yeah, just saving all of the files right now. I haven't tried running anything. But that will come up very shortly. All right, so any questions about what I just did regarding making this database script, or doing the setup.sh file from before, anything like that.
Would you need to have an execute and a query answer or some sort of variable to store execute like one by one?
That's a good question. So there is a way to see, I think there should be if we type cursor dot execute, there is a way to execute multiple queries, if I recall correctly, that you can do. You also only really need like a fetch all if you want to get the results of your query back. If you don't care about the results of the query, you don't need to use it. Any other questions? All right, perfect. So, where do I go from here? What do I do? So I think Vincent or Matt, one of you guys talked about running some setup files. Walk me through that. What do we need to do to get this online?
You should just be able to run that setup file in the bash that you created earlier to build it and then run it.
So let's do that. So we'll go to my book publisher database and we'll just do, let's see, /setup.sh. Oh, I need to open Docker on my computer. That's why it's not working. Oh, it is working. Okay, interesting. Or I think it is. Let's see once it stops lagging. All right, cool. So I've now gotten my Docker up and running. So is there anything else that I really need to do before I run my Python file? Okay, maybe not. So let's see. So let's go to our backend code and let's just do Python dbscript.py. Ta-da! We now have gotten successfully retrieved data from a SQL database using Python. I mean, the evidence is right there. So, I mean, none of this stuff was in our Python code. This is pulling all of that information from your SQL database and yoinking it into a Python readable format. I mean, this is just, well, let's see, let's talk about the data. So, let's see, who have I not heard from yet? Charles, what format is the data that we got back from our query in Python?
It appears to be not quite key value pairs, but it's like a list. Could be key value pairs. You've got a whatever the ID number for each entry is, and then the name associated with it.
Yep, exactly. So I mean, or more specifically, it is a key value pair, but it's the primary key, right? The index is the first thing linked to the column name or the name of the author in question. It sets it up as a tuple. So what you get back in your query is a list of tuples. This is important to know for when you start processing your data later on. All right, so this was how to do it on, I guess, quote unquote, easy mode. However, one thing to keep in mind is we just ran the Python code in our shell natively, right? I mean, I created a I started running the SQL code or the SQL database in a Docker container. After I ran it in the Docker container, I used Python to enter into the Docker container and got this result out. But let's be honest, is running something outside of a Docker container to get into another Docker container really the best strategy? Not really. So instead, what we probably should have done is created a Docker file for our Python code, run that in Docker, or run that as a Docker container, and then interface between two Docker containers instead of between Docker and the Insight other thing. All right, so let's go ahead and figure out how to do that. So the first thing that we should do is figure out where the database Docker stuff is taking place. And we can do that by typing Docker PS. So this tells you, what containers are running, gives you container ID, the image, it tells you if it's working, and it shows the ports. You're going from localhost to 5432. Now, in order to figure out the address, the way we can find the address based on the container ID is by using docker inspect. I'm going to be back in like 1 minute. All right, so the way that you can grab an IP address of a Docker container is by typing in docker inspect, the container ID, and then grep, which is a command that you can use to grab essentially a characteristic of a port IP address. And we see here that I've retrieved the IP address, which is 172.17.0.2. Fairly standard format for a Docker IP address. More than likely, if you guys try pulling up Docker on your computers, you'll see the exact same IP address. So I would not be too worried about that exposing anything sensitive on your computer or anything like that. All right, cool. So we've got that address. What do we do with it? So let's go back to our dbscript.py. And remember, our entire goal right now is to create a Docker file, all right? Because we need to create a Docker file in order to make our Python script run in a Docker container. So let's go ahead in here and just make a Docker file. This is why it's important to also keep the backend code distinct from the location of your database, especially if you want them running in two separate containers. So I know I just posted in a bunch of code, which is not super helpful, but I'm going to walk through it in a second. So our Docker file has a couple of things. What we're essentially doing is we're saying, hey, from Python, we want you to treat this as a source directory, run install scicopg2, which is basically what we did, except here we're telling it not to run the binary version. We're telling it to copy our database script and then run the command Python with input database script.py. Basically, what we're telling this to do is install scicopg2 and run our customized script. That's about it. All right, so there's one or two last things that we do need to do before we can keep going. So let me find where's my DB script? Here we go, DB script. So there's one or two things that we're gonna have to change about this. Does anyone know what those might be or? All right, So what's the main change that I just made between working code and now messing around with Docker?
I think you're gonna want to change the host and the port, right? Because you got the. Maybe not. That's my initial guess.
Mm-hmm. Yeah. So for the host, we're going to change it now from localhost to the IP address of your Docker container with the database. That's going to go there. Now, because we're interfacing not with our local host anymore, but with that Docker container directly, we don't need to do port forwarding anymore. We can just do it directly with port 5432. We don't need to go through our forwarding or anything like that at all. Otherwise, we don't actually really have to make any other changes. Everything else is pretty much the same. Okay, so just do an ls here. Make sure I've got my Docker container still running. Let me just do a Docker PS. So my database one is still running. And now I want to run my Python image.
You're still
So,
sharing the VS Code.
oh, thank you. All right, what about now?
Good.
Shell. Okay, cool. So just checking my folders, I'm checking that my original Docker container is still running. And now I'm going to build and run the Docker container for my Python. So we'll build it. All right, build looks successful. And now we should be able to run the container. And we get the exact same thing. So did we get any benefit directly by running this between a Docker container and Python, or a Python Docker container with Python and another Docker container with SQL? In this immediate application, no, it gives you the same exact result. However, when you guys are dealing with more complicated backends or more complicated code bases, or you're dealing with two completely different environments, Dockerizing your backend and your SQL database and knowing how to interface between them, A, when neither of them are Dockerized, B, when one of them is Dockerized, and C, when both of them are Dockerized, is pretty important. Honestly, this is about it for lecture. Do you guys have any questions before we talk about your assignments for this evening?